students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NEET graduate. So bring out your books. Let's make your preparation stress-free. So next question is, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equals to cos inverse of 33 by 65. So first what we'll do, we'll take cos on both the sides. Since they both are angle, we can take cos on both the sides. So cos of cos inverse 4 by 5 plus cos inverse 12 by 13 is equals to cos of cos inverse 33 by 65. Correct? So this is cos of A. These are angles, right? So cos of A plus B. So formula we remember for cos of A plus B, it is cos A cos B minus sin A sin B. And cos of cos inverse something, then cos and cos will get cancel out. Cos and inverse cos will cancel out. Okay. So this is nothing but cos of A plus B is equals to 33 by 65, where A is equals to cos inverse 4 by 5 and B is equals to cos inverse 12 by 13. So if you know cos, you can find in terms of sin as well. First, let's apply the formula. Cos of A plus B is equals to cos A cos B minus sin A sin B is equals to 33 by 65. So let's take the LHS from here. So we are solving for LHS and we'll prove that this LHS is equals to RHS, which is 33 by 65, correct? So this is our LHS. Now cos of A is this. So cos of cos inverse of 4 by 5 into cos of cos inverse of 12 by 13, correct? Now we can write this A in terms of sin as well. See, here we are sin, here we have sin, right? Here cos and cos will cancel out, but here sin and cos will not cancel out. Here we have sin of cos inverse 5 by cos inverse 4 by 5 into sin of sin of cos inverse 12 by 13. So here cos and cos is getting cancelled out, but here sin and cos will not cancel out, correct? So we can write A in terms of sin as well. So if you remember Pythagoras triplets, 3, 4, 5 is the one of the Pythagoras triplet, and 5, 12, 13 is a Pythagoras triplet. Or if you don't remember the triplet as well, you can solve it. How? Let's take how you will solve. See, let's do it here. Okay. So if A is equals to cos inverse of 4 by 5 means cos A is equals to 4 by 5, correct? And similarly cos B is equals to 12 by 13, correct? So let's make a triangle where this is A, so this is 4, this is 5. Using Pythagoras theorem, this will become 3. Similarly here, this is angle B, so this is 12, this is 13. Using Pythagoras theorem, it will be 5. So you can find sin A will be equals to 3 by 5, and here you can find sin B, which is equals to 5 by 13, correct? So A will be equals to sin inverse 3 by 5 and B is equals to sin inverse 5 by 13, correct? Sin inverse 5 by 13. So instead of cos 4 by 5, we can write sin inverse of 3 by 5. Instead of cos 12 by 13, cos inverse 12 by 13, we can write sin inverse of 5 by 13. So this is equals to, this cos and cos will cancel out. So this is 4 by 5 into 12 by 13 minus sin of sin inverse. Instead of cos inverse 4 by 5, we can write sin inverse 3 by 5. Sin inverse 3 by 5, correct? into sine of sine inverse, sine of, instead of cos inverse 12 by 13, we are writing sine inverse 5 by 13. 5 by 13, correct? So here again sine and sine will cancel out. Here it is 12 into 4 is 48 divided by 65 minus 3 by 5 into 5 by 13. So this is equals to 48 minus 15 divided by 65. So this is equals to 33 by 65, which is equals to RHS. Hence proved. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.